This video is the second of 2 videos for finding a limit using an algebraic approach. More specifically, this video teaches you how to use the algebraic approach when direct substitution is not possible. Some limits may require additional algebraic manipulation before we can use the laws or properties we learned in the video, Finding a Limit Using an Algebraic Approach, Part 1. Here is an example where this may be the case. For this problem, we are asked to find the limit of the rational function as x approaches 2. However, the denominator equals 0 when x is 2, meaning that direct substitution at this point would lead to division by 0, which we know is undefined. Instead, we must algebraically manipulate this equation so that we can use the direct substitution property. First, we factor the numerator and get x plus 2 times x minus 2 divided by x minus 2, which allows the x minus 2 term in the numerator and denominator to cancel, and simplify to x plus 2. Now we can use the direct substitution method to find the limit of x plus 2 as x approaches 2, and we get 4.
So I understand that example, but I feel like this could be confusing because I may not know where to begin or how to manipulate the function to find the limit.
That is true. Some examples may take a little bit more time to figure out. If you find yourself struggling with this, you can always go back and review some algebra concepts. The more practice you have, the better you will be able to recognize the steps you need to take. Let's work through another, more difficult example. We need to find the limit of the function as x approaches -4. Like the last example, we cannot use direct substitution because doing so would cause the solution to be undefined. So, instead, we need to algebraically manipulate this function to get it into a different form. Do you know what that first step would be?
Since we can't really do much with the denominator, I'm guessing we can do something with the numerator, but I'm not quite sure what that would be.
You are on the right track. First, we can rationalize the numerator by multiplying the conjugate like this. Can you simplify this?
Sure. First, we multiply the quantities in the numerator. Doing this, I get x squared plus 9 minus 25. Now, we must multiply the denominator by the same factor.
Before you continue, I want to ask you this. In the current state of the expression, is there something you can do to the numerator to get one of the terms in the denominator to cancel?
I guess I can simplify and factor the numerator.
Exactly. Please continue down that path.
Simplifying, I get x squared minus 16. This factors to x plus 4 times x minus 4. I can now cancel x plus 4 in the numerator and denominator, which equals x minus 4 over square root of x squared plus 9 plus 5.
Excellent. For problems like this, it is typically helpful to not multiply the factors in the denominator. This is because we want to attempt to manipulate the numerator so that we can cancel a like quantity in the denominator. If you had continued earlier to multiply the quantities in the denominator, then you would not have been able to readily cancel the x plus 4 term. Now you can solve the limit of this expression as x approaches -4.
Okay, I see. So now we can solve the limit by substituting -4 for x into the function, which equals -4/5.
Your answer is correct. You will find this process gets easier each time you practice.